guys, it's Miss Damaso. Welcome to our week 2 video 2 notes, our second video of the week. We're going to be talking today about finding the volume of spheres. A quick reminder, as I'm sure you probably already know and have gotten the hang of at this point, our notes are on Edmodo. If you go into the assignment week 2 video 2 homework, you will see both a PDF for the notes as well as a PDF for the homework. So as we're going through the notes, you are welcome to take notes with me. If you have a printer, you can print them off. And if you don't, you can do them on a sheet of paper. That works just as well. So today we're going to be finishing up our volume, and we're going to be talking about volume of spheres. So we have already done volume of pyramids, prisms, cylinders, and cones. This is our last section, and we're talking about spheres, and a sphere is essentially something that looks like a ball, essentially, is what we're looking at. So the first thing that we have to make sure we know are that there are different parts of a sphere. And there's a couple different parts. So number one, this point that's right in the middle of the entire sphere is our center. And that kind of makes sense, right? Because it's right in the middle. A sphere is a solid where each point is equidistant from the center point. That means every point around this sphere, whether it's up, down, left, right, behind, in front, all of them are the exact same distance from this center point. So equidistance means they're all exactly the same distance. There are other parts that you probably already know as well. If it goes from the center to one edge of the circle, this piece right here is called the radius. If it goes from one end of the circle, the sphere, to the other end of the sphere through the center point, that is double the radius, which is called the diameter. The last part is called a great circle. So a great circle slices the sphere into two hemispheres. So it essentially takes my sphere and it cuts it in half. So I've got one half of a sphere on top, one half of a sphere on the bottom. That's called a great circle. And that's how, of course, we have, if you think about the globe, right? The Earth is a sphere, and so you've got the northern hemisphere, which is where we live, and then you've got the southern hemisphere, right? So hemisphere is half of a sphere. Okay, so our volume formula for a sphere that we're going to be using every time is volume equals 4/3 times pi r cubed. The r stands for radius. So we're going to have to make sure that we know the radius in order to find the volume. So for each one of these, we're going to find the volume of the spheres that are listed here. First thing I'm always going to look for is the radius. So radius goes from the center to one of the edges. That's what I have right here in my picture. I'm already given that the radius is 7. So because of that, that's the only thing I really need for this formula. So I can plug it right into the equation. Okay, so I've got 4/3 times pi times my radius cubed. So my radius is 7. And I'm going to cube it. Now, when we did volume of pyramids and cones, it was 1/3 times all this kind of jargon and all these other numbers. This is essentially the same thing. It's multiplied by 4 on top and then divided by 3 on the bottom. If you like the way it looks, if I make them all fractions, like what we did before in our last video, you can put them over a 1 if that helps you out. So the first thing I'm going to do is I'm going to do 7 cubed because I know order of operations says I have to do exponents first. So if I do 7 cubed, that means 7 times 7 times 7. Now, on your phone, you might have a cubed button. I'm hoping maybe you do. It should be, instead of like an x to the squared, you should have like an x with a little cube. I don't have another phone to show you with, unfortunately. But if you don't have that, you can always just do 7 times 7 times 7. You can do 7 3 times, right? So 7 times 7 times 7. That's the same thing as 7 cubed. So if you can't find that button, this is an okay way to go about it too. So 7 cubed is 343. So my equation really becomes 4/3 times pi times 343. Again, I'm putting them over 1, and I'm going to go straight across. So I'm going to multiply everything on top first, then I'm going to multiply everything on the bottom. So on the top, I'm going to multiply 4 times pi, remember to use the pi button, you should have one, times 343. I get a very large number, 4,310.27, and then I'm going to divide that by 3 times 1 times 1, which is just a 3. Leave the whole number in your calculator or your phone as you divide by 3 because it's going to give you a more accurate number. So you want to make sure you're not rounding too early on. You want to round at the very end. So keep the whole number in your calculator. I just wrote it over here because I didn't want to write this whole thing. Okay? Take that number, divide it by 3. You get the volume of your sphere is 1,436 point, we'll go to 2 decimal places, 76, and then my label's inches, volume is cubed. And there we go, nice and easy. So don't let the 4/3 scare you. That just means you're gonna multiply by 4 on top and divide by 3 on the bottom. Easy peasy. Okay, number 2. Number 2, I am not given the radius. I am given the point that goes from the edge to the other edge through the center. This is the diameter. To find the radius, I'm going to take that diameter of 33, I'm going to divide it by 2. So when I do that, I get 16.5. And now that I have the radius, that's all I need to figure out the volume of a sphere. I'm going to plug it into the equation. So volume equals 4/3 times pi times radius cubed. So 16.5 cubed. I'm going to put them over a 1 like I did in my last problem. First thing I'm going to do is I'm going to figure out what 16.5 cubed is. Again, if you don't have the cubed button, you can do 16.5 times 16.5 times 16.5 3 times. Or if you've got a calculator like this, there's this little thing that's called a caret. That means 16.5 to the whatever power you want, to the 3rd power. That's a very large number. Okay, so this one is 4492.125. All right, so now knowing that, I'm going to multiply 4 times pi times 4492.125, and then essentially I'm going to divide it by 3 times 1 times 1, so I'm really just dividing this whole thing by 3. It's another way to write the same thing, right? This is exactly the same as this. I'm just rewriting it a different way. So you can do whichever way makes you happy. I kind of like this way more, and I might start doing it this way. Okay, so I take this number, I multiply it times pi times 4. I get a very, very, very big number. I'm not going to write that whole number down. I'm now going to take that and divide it by 3. So I get my final volume is 18,816 and 50. So this is 56. It's got 56.9, right? The 9 means you bump the 6 up to be a 7. And my label's centimeters cubed for volume. All right, not that difficult. Let's do one more. All right, so I've got volume equals, so I guess the first thing I should really do, right, is look for my radius. Don't let this fool you. It isn't straight up and down or straight across like our last one, but radius just means it goes from the center to one of the edges, and that's exactly what I have here. So my radius for this problem is 2.8. Don't let that picture the way it looks fool you. So I'm going to do 4/3 times pi times my radius cubed, 2.8 cubed, over a 1 over a 1. First thing I'm going to do is figure out what 2.8 cubed is. So I'm going to do 2.8 to the 3rd power. I get 21.952. So now I'm going to multiply everything on top together and then everything on the bottom together. 4 times pi times 21.952, And then I'm going to divide the whole thing by 3 times 1 times 1 is 3. So if I multiply those numbers on the top, I get a large number, 275, and then I divide it by 3. So my volume is, and again, we're going to round to 2 decimal places, so I'm going to do 91.9, and then after the 5 is a 2, so it stays a 5, 91.95. My label's meters cubed. And there's my volume, okay? So a sphere is really easy. The only thing you need to know in order to do a sphere is the radius. That makes life super simple. Now, the next one is a hemisphere. Hemisphere means half, right? It's half of a sphere. So instead of multiplying by 4/3, half of 4 is 2. So we're going to multiply by 2/3 and then pi r cubed again. It's exactly the same thing. It's just my fraction's a little bit different. Okay, so my radius for this problem is 5, right? Because it's given to me. It goes from the center to the edge. And now I'm just going to take that number and I'm going to plug it in to the volume equation. Okay. So I've got volume equals 2/3 times pi times radius cubed. So 5 cubed. That means 5 times 5 times 5. Well, 5 cubed I know is 125. So I'm going to multiply all my numbers on the top together, all my numbers on the bottom together. So I'm going to end up doing 2 times pi times 125, and I'm going to divide it by 3 times 1 times 1 is 3. And now it's just a problem for my calculator. 2 times pi times 125, and then I divide it by 3. My volume is 31 point, now this is 41, the number after the 1 is a 5, so it rounds up to be a 42. And then I've got kilometers cubed. Okay. Oh my, you know what? I was just looking at this. I feel like I plugged in something wrong. So let me do this one more time. 2 times pi times 125. That's a bigger number. I was just going to say that seemed really, really small. Whoops. Okay, so I apologize for that one, guys. Mr. Masso making mistakes. Okay, so when I divide those, I actually get, so I must have pushed something incorrectly on my calculator. So this is 79. If I round it up, it would be 80. So I apologize for that. I clearly pushed something incorrectly on my calculator, which I realized was wrong very quickly. Okay, next problem, number 8. I am not given the radius, but I am given the diameter. So in order to find the radius, I'm going to take 18, I'm going to divide it by 2. My radius is 9. So I'm now going to put that into my equation. 2/3 pi radius cubed, 9 cubed. All right, I know 9 cubed is 9 times 9 times 9. That is 729. So I'm just taking those numbers and I'm plugging them in. So I'm going to multiply everything on top. That's a 2 times pi times 729. And I divide it by 3 times 1 is 3. Okay, so let's be careful this time so I don't get the wrong thing. 2 times pi times 729 equals 4,580, and then I divide it by 3. I get, that looks about right. My volume is 1,526 point, I've got 81, the number after is a 4, so it stays 81. And then feet cubed for volume. All right, one more. Easy stuff. Again, I am given, so don't let the picture fool you. It goes from the center to one of the edges. That means my radius is 14. Don't let that picture fool you. So it's volume equals 2/3 times pi, put it over 1, times my radius cubed. That's 14 cubed. Now, I'm going to do 14 cubed first. I don't know what that is off the top of my head. I get a very large number, 2,744. I'm now going to multiply all the numbers on top and then all the numbers on the bottom. So I'm going to do 2 times pi times 2,744, and then I'm going to divide it by 3, right? Because 3 times 1 is 3. Okay, so this is going to be a big number. Oh yeah, look at that number, 17,000. Woo! And then I divide it by 3, and I get my volume is 5,747 point. I've got O2, the number after the 2 is a 0, so it stays O2. My label is yards, and it's cubed for volume. All right, and we're done with hemispheres. So look at you just did spheres and hemispheres. Hopefully, you see that they're actually not that difficult. Even though you've got a fraction, you really only have to plug in one number, which is the radius. So hemispheres and spheres are probably the easiest ones when it comes to volume. All right, now we're gonna do a couple application problems. So we're gonna take all the knowledge we've kind of learned about spheres and hemispheres, and we're going to apply it to some real world problems. Okay, number 7. Excuse me. Find the volume of a sphere with a great circle area of 201.06 square inches. Now, a great circle is just a 2D shape that slices my sphere into 2 equal parts. So a great circle, right, would be something, it's over here. This is my great circle. My great circle is just a 2D shape. And guess what that 2D shape is? A circle. So all I have to do is I'm going to say, okay, I know how to find the area of a circle. I already know the area of my circle is this one right here. Now, I'm going to use that to find the volume. In order to find the volume, you must have one number. And the one number you must have is the radius. So what I'm essentially trying to do is first I have to find the radius before I can do anything. Okay, now, great circle area. The area of a circle is pi r squared h. Or sorry, well, there's no h. Whoa, Mr. Masso, okay. Pi r squared, excuse me. That would be a 3D figure. This is a 2D. Just pi r squared. Now, I know the area. The area is 201.06. So I'm plugging that in for A. Equals pi times r squared. I'm going to solve for r so I can find the radius. This is pi times r squared. In order to get rid of the pi that's over here on the right, because I just want to have an r, in order to get rid of pi times r squared, I'm going to divide by pi. And whatever I do to one side of the equation, I have to do to the other. Now, on the right side, these pi's cancel. I'm left with just an r squared. This I'm going to put into my calculator. I'm going to do 201.06 and divide it by pi. I get 63.999, so we're going to round that up to be 64. We're going to round to the whole number. In order to get r by itself, now this is r squared, to get rid of the squared, I'm going to square root. The square root of 64 is 8, right? 8 times 8 gives me 64. So I found my radius. That's great. Now that I have my radius, I can find the volume. So to find the volume, I've got a sphere. So my formula for a sphere is volume equals 4/3 times pi times r cubed. Now we're going to plug in our info. 4/3 pi, my radius is 8, so I'm going to do 8 cubed. 8 cubed means 8 times 8 times 8. That gives me 512. I believe I should check that. Yep. Okay, 512. So now I'm going to multiply everything on top and everything on the bottom. So I've got 4 times pi times 512 over 3 times 1 is 3. So now it's just a job for my calculator that I don't even need to think about. 4 times pi times 512 divided by 3. I get that the volume is 2,144.66. And I'm talking about inches because it's volume. It's cubed. And there's my final answer. For the next problem, I'm going to find the total volume of the given figure to the left. Now, if you look at this figure, you will notice there are 2 different pieces to it. I've got down at the bottom what looks like half of a ball. So this number down here is a hemisphere. And I've got what looks kind of like a party hat on top, which is a cone. So I have to find the volume of a cone, the volume of a hemisphere, and then I have to add those 2 together. All right. So why don't we do the hemisphere first, because that one is easy peasy. Okay, to find the volume of a hemisphere, my equation is 2/3 pi r cubed. All right, now I have the diameter is 9. To find the radius, I'm going to divide 9 by 2, which gives me 4.5. So now I'm going to plug that into the equation. 2/3 pi 4.5 cubed. Order of operation says I do 4.5 cubed first, and that is 91.125. So I'm going to do, volume equals 2 times pi times 91.125, and then I'm going to divide that by 3. So when I do that, just put it in my calculator, I get the volume of the hemisphere is 190.85 meters cubed. That's just the hemisphere. Great. Now I've got to find the volume of my cone. So hopefully you remember from our last video, to find the volume of a cone, my formula is 1/3 pi r squared h. Okay, so I know the radius of this cone because it's the same radius as the hemisphere. It's just this 1/2, so it's 4.5. However, I do not know the height, the vertical height of the cone. However, this should look familiar. That is a right triangle. And that right triangle I can solve for by using the Pythagorean theorem. Woo! Okay, so I'm going to draw myself a right triangle so we can solve. I know at the bottom it's 4.5. I know this slant height is 13. I have to find this height over here on the other side. So I've got a squared plus b squared equals c squared. A squared is 4.5 squared. B squared is what I'm trying to find. C squared is 13 squared. Okay, I'm going to square the numbers first. So the first one I get 20.25. Got to solve for my b, and 13 squared gives me 169. From here, I want to get b squared by itself, so I'm going to subtract 20.25 from both sides. I get b squared equals 148.75. And my last step to get the b by itself, I square root. So I get b is about 12.2. So that is my height. Now I've got the radius and the height, so now I can find the volume of the cone. So much work, guys, so much work. Okay. So I have volume equals 1/3 pi. My radius squared is 4.5 squared times my height is 12.2. I'm going to multiply everything on top, and then I'm going to multiply everything on the bottom. Now, first thing I got to do is, of course, the 4.5 squared, because we know that order of operations says that's what I've got to do. This number right here is 20.25. So now I'm going to multiply 1 times pi times 20.25 times 12.2, and I'm going to divide the whole thing by 3 times 1 times 1 times 1, which is 3. So now I'm just going to put this into my calculator. Times pi times... Okay, I get 776, and then I divide it by 3. I get the volume of my cone is 258.71 meters cubed. Now the last step is I need to find the total volume. So to find the total volume, I'm going to take the volume of the hemisphere. I'm going to add the volume of the cone, and that's going to give me the total volume. So I'm going to add together 190.85 plus 258.71. And when I do that, 85 plus 258. I get the total volume is 449.56 meters cubed. And that is my final answer. So that one was definitely a lot of work because it was a composite figure. Composite means a composition of more than one figure. So there were 2 figures there. So that one took a little bit more work. Number 9. The diameter of a standard basketball is 7.4 centimeters. How many cubic inches of air would it take to fill 3 basketballs? So I want to find the volume of 1 basketball, and then I want to add it together 3 times, or multiply it by 3. That will give me the total volume of 3 basketballs. First thing I got to do is I know that the diameter is 7.4. Well, in order to find the volume of a sphere, I need to know the radius, not the diameter. That's unhelpful. So to find the radius, I'm going to take the diameter and divide it by 2. And when I do that, I get 3.7 is my radius. Now I'm just going to take that and I'm going to plug it into the volume formula of a sphere. So volume formula of a sphere is 4/3 times pi times radius cubed. So I've got 4/3 times pi, and my radius cubed is 3.7 cubed. Order of operations says I do 3.7 cubed first. Put these all over a 1 if you like. So I've got 4 times pi times 50.653, and I divide the whole thing by 3. So now it's just a moment for your calculator. Multiply everything on top. I get 636 and I divide it by 3. So my volume for one sphere equals 212.17. Well, I want to know the volume of 3 spheres. So I'm going to take my 212 and I'm going to multiply it times 3. And that's going to give me my total volume. So if I do 212.17 times 3, the volume of 3 basketballs is 636.51, and then it's inches cubed. So we found the volume of one sphere, and then we multiplied it times 3 because it's asking me for how many it takes for 3. Last question. A hollow sphere sits snugly in a foam cube so that the sphere touches each side of the cube. The cube has dimensions of 12 inches. Find the volume of the foam. So I've got a ball that's inside of a cube or a prism. It's like inside of a box. So I'm going to take the area of my prism and I'm going to subtract the area of the sphere, and that will give me what's left over inside of the box. Okay, now we got to kind of think back just a little bit. The volume of a prism, okay, a prism or a cube is, hopefully you remember, anytime it looks like a box, it's just length times width times height. Now, I'm only giving one number here. I'm told that the cube has dimensions of 12 inches. Well, if it's a cube, that means all of the sides are exactly the same. So if this length is 12, well, that means this one is 12, this one is 12, and so on and so forth. Every single one of those is 12 inches. So my volume is going to be the length is 12 times the width is 12 times the height is 12. So 12 times 12 times 12. If I do that, I get the volume of my prism is 1,728. That's my first part. My second part is I've got to find the volume of my sphere. The only thing I need to know for a sphere is the radius. Now, I am given the entire side length. That means it goes from one edge of the sphere through the center to the other edge. That means it's a diameter. The diameter is 12. Well, if the diameter is 12, the radius has to be half of 12. Half of 12 would be 6 inches. So when I go to plug this in, I'm going to make sure I plug in 6 for my radius. Okay. To find the volume of a sphere, okay, so it's a sphere, not a hemisphere, I do 4/3 times pi times radius cubed. Okay, so we're just going to plug in some numbers based on what we've got here. So I've got volume equals 4/3 pi. My radius is 6. We're going to cube 6. So that means 6 times 6 times 6. I get this number right here. It's really 216. Okay, so I'm going to do everything on top times everything on the bottom. 4 times pi times 216. And I'm going to divide it by 3 times 1 times 1 is 3. Now it's just something my calculator is going to do. 4 times pi times 216, and then I divide it by 3. So the volume of my sphere is equal to 904.78. Okay, so the sphere is hollow. So now here's what I'm going to do. To find the total volume, all right, total volume, I have to take the prism volume and subtract the sphere. And I'm doing that because the prism itself is solid, but the sphere is hollow, so I'm taking it out. Anytime it says hollow, that means you're taking it out, right? It's not there anymore. So the prism is 1,728, and I'm going to subtract 904.78 from that. 904. So I end up getting that the total volume of the foam, right? Find the volume of the foam that's left over is 823.22, and it's inches cubed, right? Because it's volume. All right. So now we have completed our week 2 video 2 notes. So this is kind of the end here of 3D shapes. So you're going to go into Edmodo, back into the assignment. You're going to now complete the week 2 video 2 homework. You're going to make sure you submit it on Edmodo through the assignment. You are not sending me a message with your work. You are not sending it to me on Focus. You are not sending it to me on Microsoft Teams. You are sending me your work through this assignment on Edmodo. If you do not remember how to submit something on Edmodo, you can go into my YouTube page, and I did post a video called How to Submit to Edmodo. Okay, so we're all finished for today. You can go on to your homework now. If you have any questions, feel free to message me on Edmodo. Have a great day.